Okay. So whatever points I'm telling about the threads, I hope you are able to understand that. Otherwise, ask me the query immediately. But threads have certain disadvantages also. Okay, two disadvantages I would like to highlight here. One is timing faults. Now, if I say that there are multiple strands of execution, and that there is a function executing on every strand, every core, obviously all the threads are executing within the single process. So single process spread on multiple cores. So the threads must have been started with some purpose, manipulating some data. So there is every chance the threads will mess up the data. Therefore, timing faults happen. And what these kind of timing faults happen, the data is corrupted, then debugging becomes very, very difficult. So timing faults and debugging are two major issues in threads. The multiple threads within the process would give performance gain only if sufficient hardware is available. Okay. So timing faults and debugging, we have to be very careful about timing faults and fully concentrated while debugging. Okay. Now, as I said that threads are reentrant functions. Now let's have a look at these. What is that reentrant function? Normally what happens is when you execute a function, it executes like this. So you'll have a thread executing, program executing, and that program makes a function call, and then the function executes. If the function is over, control returns back to the main function, and then the main function continues. Otherwise, the main function wasn't waiting for the other function to finish its execution. So this is suppose main function, and this is your another function. So here you had some kind of wait for the other function to finish. But when you execute reentrant functions, one function is executing fine, it calls another function executes. Then the main function does not pause or wait for the other function. Instead, main function also continue executing on one core of the CPU. Another function also execute on another core of the CPU. When the main function continues further, it may invoke another instance of the same function or another instance of the same function. So you can have multiple instances of the same function executing simultaneously along with the main function on different cores of the CPU. This is what is the behavior of threads. So this property of the function is called reentrancy, and such functions are called reentrant functions. Okay. So threads are implemented as reentrant functions. Okay. Now, when you have to use threads, you have to implement the reentrant functions. Okay, that will execute concurrently on another core of the CPU. Such functions were not supposed to be part of Linux right from the beginning. It was later realized that the concept of threads is essential and is needed in Linux. So a separate set of thread libraries was created. But those thread libraries could not be made part of Linux operating system permanently. So those thread libraries are till date kept separately from the Linux kernel. And whenever you have to use those threads in your program, whenever you have to use those thread libraries, you should import those libraries at the compile time. and importing those thread libraries at the compile time is done using -lp thread. LP thread means link POSIX threads. Important point. Link POSIX threads. Okay. Now, how to create a thread? Normally, if you implement a function, say the name of the function is my function. So how would you invoke the function? Call that function, give the name of the function my function, and that function will be called. But if you're creating a reentrant function, if you're creating a thread function, then you will not invoke that function by calling that function. Instead, you will use pthread_create system call. Pthread_create system call to invoke, to create the thread, or in other words, to create the thread function. You will have to use pthread_create. The pthread_create system call would take 4 arguments. Let me explain this to you. The pthread_create is used to create the thread function. Used to create a new thread function. It returns 0 for success and -1 for failure. Now, the moment it returns, see, read this carefully and understand. The moment it returns 0, the thread function starts to run on different core of the CPU immediately. Okay, where is that function? Well, this is that function. The pthread create would return 0. Yeah, for success. When it returns 0, it means the moment it returns 0, the thread function, this one, this is the function name, will start executing on another core of the CPU. Okay. Watch this. This is the prototype of the thread function of the thread function that is reentrant function. Okay, if you notice carefully, it is implemented as generic function. You are already implementing generic function when you have used array of function pointers, so you will not find it very difficult, isn't it? It takes void pointer as argument and it returns void pointer. Okay. The first argument, this one, this is the thread ID. When the thread will be created and starts to run on other core of the CPU, the thread ID will be written to the location pointed to by this pointer. You will not give the thread ID as first argument. You will just create a pointer of type pthread_t and just leave it. When the thread will be created successfully, thread ID will be written here. So this is an implicit argument. Okay. The second argument that you see here is actually thread attributes. This one, ADTR. These are your thread attributes. It describes how the thread will be created, run, communicate, schedule, or terminate, etc. But these things we'll see later. First, let us learn how to create threads. Okay. The last argument, void star arg, that you see here. This is the argument that could be supplied to the thread function when the thread function would be launched. जब भी thread function run होगा, देखो pthread create मान लेते हैं main function ने कॉल दी और main function ने एक function बनाया thread function. So pthread create से thread function बना, तो ये जो fourth argument है void star rg, ये main function से thread function को चला जाएगा. So this is actually the argument that will go here when the thread will be launched. This is how the threads are created. So when you run a function, say the main function would execute. And main function, when execute, gives a call pthread_create call. When it will give this pthread_create call, a thread function would be invoked on other core of the CPU, and the thread function will start executing on other core of the CPU, say here, because of pthread create, this thread would be created from here, and it will execute its own function. Main will execute its own function on different cores of the CPU. Then when the thread will finish, then the last statement of this thread function will be pthread underscore exit. So pthread underscore exit system call would be given by the new thread, which is indicator that the thread is over. Okay. Now when the thread goes over, it will also give exit code, which has to be captured by the creating thread. This exit code is important because see, the main thread would have created other thread, or maybe other thread have created more thread for some purpose, for some reason. Maybe it wanted some result. So this exit code will solve that problem and produce result information, which will certainly be needed by the main thread. So therefore, this exit code is number one, very important. Number two, you have to learn how to fetch the exit code that is exited by the pthread exit. Okay, that's the second thing we have to learn. So when the thread is created, the thread function starts to run immediately on other core of the CPU. Pthread underscore t represents the thread ID. It's a pointer to the new thread ID. When the thread is created, an identifier is written to the memory location to which it points. The thread identification table is maintained within the process context. Now every process context maintains a table of threads that are currently executing in your process on different cores of the CPU. All the created threads are listed in that table. Attributes. Attributes will define the thread behavior, like how the thread will be created, behave during execution, synchronize, communicate, terminate or exit, all these things that we'll see later. For now, we'll keep these thread attributes as null because our concentration right now is to learn to create threads. The thread routine, the thread function, which is actually going to be your reentrant function. Now this is a user-defined function. We will write these functions. So this is a reentrant function because you'll have multiple instances of this function running simultaneously on different cores of the CPU. It returns void and takes void arguments, so these are implemented as generic functions. And this is the reason because almost everything in the system programming, network programming, device driver programming, kernel programming, everything is implemented as generic functions. So therefore I have already given you the practice for generic functions and multiple data compression. It should run on other core of the CPU if available. If other core of the CPU is not available, then it will see where the load is less on which core of the CPU. It will go on that core of the CPU. Okay. It starts to run immediately when the pthread create returns 0. Okay. This is the argument. Now from the creating thread to the created thread. Now this argument is supplied from the creating thread and goes to the created thread in void star argument. So you know you can typecast and pass any argument that you want to, isn't it? So using fork, the program counter of the parent process is copied to the program counter of child process. See, remember, try to recall, you did fork. When you did fork, what happened? The moment you created the child process, the program counter of the parent process, which was referring to the fork statement to which the fork statement was running, that program counter was copied to the program counter of the child process. So the child process start executing from fork statement onwards. All the statements were executed by both parent and child. But when you create thread, then the program counter of the parent process is not copied to the program counter of thread process. It actually different task structure is not created. Okay, listen this carefully. All the threads will use the same task structure of that of the main thread. So there is only one task structure for all the threads created. Then how is it possible that multiple threads executing? Well, because every time you create a thread, a new program counter variable is created inside that same task structure. I repeat, every time you create a thread, a new program counter variable is created inside the task structure. That new program counter variable inside the task structure will point to the new thread function, reentrant function, that will execute on different core of CPU. Okay, you got that? So if you have executed 10 threads, created 10 more threads in your process, so other than the main thread, main program counter, you will have 10 more program counters pointing to 10 different reentrant thread functions. Okay, and then finally pthread exit will exit your thread. Fine. So guys, this was an introduction to threads where I told you how the threads are created and exited. In the next session, we will continue and we will implement this and create threads and make them run on different cores of the CPU. So practically we'll do it in the next session.